Hey, space cadets, welcome back! How about if astronauts come back from space younger than they left, like Captain Kirk defying wrinkles for decades? Buckle up, because today we're blasting off to explore the myth of astronauts aging slower in space. Now, wouldn't it be something if space travel was the secret to eternal youth? If every trip to the stars was like a dip in the fountain of youth? That's the picture painted by many a science fiction tale. But as we're about to discover, reality is a tad more complex than that. So, is there a kernel of truth to this myth? Is there some cosmic wrinkle cream at work in the cosmos that keeps our astronauts youthful? Or is it all just the stuff of science fiction? This is a classic sci-fi trope, but the truth is much stranger. It all boils down to a mind-bending concept called time dilation. You might remember a certain hair-tousling genius by the name of Albert Einstein. Well, according to his theory of relativity, time doesn't actually tick at the same rate for everyone, everywhere. In fact, time runs ever so slightly slower for objects moving really fast or hanging out in strong gravity. Now let's take this concept for a spin. Picture the International Space Station, ISS, circling Earth at a breakneck speed of 17,500 miles per hour. That's faster than a speeding bullet, folks. But wait, there's more. Even though Earth's gravity isn't as strong as, let's say, a black hole's, it's still significant. So when you combine the ISS's high speed with Earth's gravity, you get a sort of time bubble around the ISS. And inside this bubble, time ticks just a smidge slower. Now I can almost hear you wondering, how much slower are we talking? Well, prepare to have your mind gently blown. For a typical 6-month mission on the ISS, an astronaut might age a few thousandths of a second slower than their pals back on terra firma. Sounds wild, right? But before you start packing your bags for a space vacation in the hopes of eternal youth, let's get real. The effect is so tiny it wouldn't even make a dent in your aging process. We're not talking about coming back from space looking like you've just stepped out of a time machine. So while time dilation is a cool phenomenon, it doesn't make astronauts the Peter Pans of the cosmos. But it does give us a fascinating glimpse into how the laws of physics can get all twisty-turny in extreme environments. Even though Earth's gravity isn't super strong, these two factors combined create a tiny time bubble around the ISS, where time ticks ever so slightly slower. So, how much slower are we talking? Let's put our thinking caps on and dive into the math behind this fascinating phenomenon. For a typical 6-month mission on the International Space Station, an astronaut might age a mind-boggling, wait for it, a few thousandths of a second slower than someone back on Earth. Yes, you heard it right. We're talking about thousandths of a second, not years, not months, not days, not even minutes. Now, that's not to say this effect is insignificant. On the contrary, it's a profound demonstration of Einstein's theory of relativity in action. But let's be real, you're not going to notice a difference of a few thousandths of a second when you look at your astronaut friend. They're not going to come back from space looking like a fresh-faced teenager. In fact, if you were hoping for a sci-fi-style time-traveling fountain of youth, you might be a tad disappointed. The difference is so minuscule it wouldn't even register on your grandma's wrinkle cream commercial. But don't let this burst your cosmic bubble. Time dilation might not be the secret to eternal youth, but it's a fascinating example of how the laws of physics can have surprising effects when we venture beyond our home planet. So the myth of astronauts defying age is busted. Time dilation, as mind-bending as it may be, does exist, but its effect on aging is incredibly small. For an astronaut on a 6-month mission on the International Space Station, they might age just a few thousandths of a second slower than someone on Earth. It's not exactly a ticket to eternal youth, but it's a fascinating glimpse into the strange world of physics. Still, it's a mind-blowing example of how physics works differently in extreme environments.